Science today is big, bold, and visionary. So advanced is our knowledge becoming that to make progress in any field, it's necessary to call on ever greater computer power and bring together the brains and resources of many different countries to create complex virtual laboratories. To do this requires a huge volume of fast data communication and the pooling of widely separated computer resources. Europe's many e-infrastructure projects are a response to these needs, and the emerging virtual research communities depend on them. Europe is a family of many different countries, each offering their own scientific insights. Now these e-infrastructures are giving this family a new way to interact. Meeting Europe's needs for networking and connectivity is GÉANT 2, the backbone of the continent's e-infrastructures. It's operated by Dante and co-funded by the EU.
GÉANT 2 is an enabling technology par excellence, and it is also a wonderful example to show how one can efficiently bring together the capacities of national governments, of the EU and of industry.
Splaying out the end of a GÉANT 2 fibre optic cable shows the ultra-high capacity light beams that the network utilises.
GÉANT 2 is certainly the most advanced network in the world. Now we're moving away from the router-based technology, which is at the heart of an internet network, to providing what is called a hybrid network, which consists of a combination of router and switching technologies.
GÉANT 2 uses up to 96 different optical wavelengths, and each colour can carry a separate circuit. This meets the needs of certain experiments, for example radio astronomy, to have their own network of dedicated high-capacity circuits.
By linking multiple telescopes spread throughout Europe, we're able to synthesize, in essence, a single virtual telescope.
I think for me, really, GÉANT 2 is part of the telescope because it doesn't work without it.
Even moving pictures can now be captured. This is a single exploding star in a far distant galaxy.
With GÉANT 2 and 60 other e-infrastructure projects, we are really moving into a new world of science, where the best brains around the world are brought together at a distance to tackle problems of a hitherto unreachable complexity. Scientists are making use of an increasing amount of data about our universe, making data repositories available for all. Biologists are remotely studying botanical collections spread all over Europe, and they are modeling systems of the building blocks of life in their virtual laboratories. Scientists are building models of our Earth in their computers to create reliable weather forecasts, to study climate change, and to develop a sustainable energy system, giving European industry an edge for the future.
Because of their overarching importance, 3 of these projects, together with GÉANT 2, are designated flagship e-infrastructures, and it's these that are featured in this film. EU-funded EGEE, Enabling Grids for E-Science, is a landmark infrastructure, meeting the need from every corner of Europe for massive amounts of processing power way beyond the resources of individual institutions. EGEE connects widely separated computer farms to a sophisticated electronic grid that enables these diverse clusters to act as one giant computer.
There is a lot of computer power available already, just spread around the world. So it seemed like the natural thing to do to just connect this computer power and make it available to all the scientists who need that.
This live monitoring of EGEE in action shows the ebb and flow of demand at computer centres. Anticipated overload at any centre is ironed out by directing the surge to where there is spare capacity at that moment. Here, EGEE is being used to simulate plasma flow in a Spanish experiment helping to design a new generation of safer nuclear reactors. This is a computer model of an enzyme on the Asian flu virus. EGEE has hastily teamed up with Asian experts to create a virtual laboratory capable of narrowing down millions of drug candidates to a manageable group with potential for inhibiting the enzyme. These can then be tested in physical laboratories. But there remain certain problems so complex they move into a different league. This is the domain of the supercomputer. Previously occupied by monks, Chapel Torre Girona in Barcelona now houses Spain's national supercomputer. Called Mare Nostrum, it's Europe's most powerful mainframe and performs 94 trillion operations every second. Many European member states have similar centres. This one's at Jülich in Germany. Supercomputers meet the need for solving complex tasks such as turbulence problems, and this global weather analysis being undertaken by the Finnish Meteorological Institute. These require all the computational elements to be done simultaneously in ultra-fast, so-called low-latency machines. Machines that can even probe the structure of our entire universe.
This is a room that houses the cosmology machine. And here it is. This is it. The cosmology machine, huge supercomputer, rack after rack after rack of computing power. This is a shrine to modern technology and a shrine to modern science. All these computers are working together to calculate the evolution of the universe. This machine is making a virtual universe as we speak. But look at this immense structure. It's beautiful. This weighs billions of times the mass of the sun.
The EU-funded DESA project has met the need to join these supercomputer centres together to maximise their efficiency and power.
The Europeans at the moment have a world lead in many aspects of computational science, and the reason for that is because in Europe we have the ability to work in teams, and that is exemplified beautifully by the DESA concept, in which it's not just the individuals who collaborate, but also the technology, the machines that work together, and in so doing multiply the ability of the individual partners.
The final flagship e-infrastructure this film looks at is OMII Europe, the Open Middleware Infrastructure Institute. It's been set up by the EU to meet the need for Europe to reach out and connect with other infrastructures around the world by integrating background programming known as middleware.
Middleware is the software that allows computers across the world to work together. So you can run your program on a computer in California, you can collect data from a computer in Japan, you can present it on a screen in London, and so on. And that has to be made as easy to use as it is for you to edit an Excel spreadsheet or something. We're trying to make all of the computers form effectively a nervous system for scientists working together on the globe, a brain that works as a unified entity.
With this suite of EU-funded infrastructures, the European Union is taking a leading role in offering researchers integrated computer services and creating a collaborative approach to doing science. If you want to know how you can create a virtual research community and benefit from creative connections, the EU has set up Belief as a point of contact. They can be visited at www.beliefproject.org.